Hello, everyone. Yesterday we learned about bonding, right? And I also named that there are two types of bonding: ionic bonding and covalent bonding. Ionic bonding takes place between a metal and non-metal, and covalent bonding takes place between only non-metals. Today we are going to learn about definition of chemical bonding in general, ionic bonding and chemical bonding. And then there is one more called metallic bond. So, metallic bond is a very interesting one, and it is slightly different type of bond from ionic and covalent. And I always insist on understanding and learning definition in that order. That means you should understand the definition of anything you are learning, and then if you can, by heart it, it helps very much, especially when you are doing writing your exam, and you are under pressure. You don't really know, that the next question is going to just unnerve you. So in that case, learning is a skill, memorizing is a skill. And please, whoever tells you that, my memory is not good and it is something to cherish, please don't fall for it. Memorization is a skill. It's a skill. And you know what? It's rarer nowadays. So let's begin with the definition of covalent bonding, ionic bonding, and hopefully metallic bonding too. So just wait for a second. So first we start with the definition, as I said. So chemical bonding. I hope that you can read my handwriting. And this is always the first thing I ask my students because I have a habit of writing in cursive. Nowadays, not many can read that. So, chemical bonding. What is chemical bonding? Chemical bonding is a force of attraction, is a force of attraction between different types of or same types of atoms, between, or I should say, same or different types of atoms. Okay, so now the everything lies here when I have said same or different types, right? So if it is same, possibility is that it would be, you know, non-metals. For example, chlorine, oxygen, nitrogen, etc. And different will be good old NaCl, calcium oxide, okay, and maybe other sodium oxide, okay. There are many, so we are just doing these examples. So these are molecules and these are compounds, okay. How they are formed and why did I write NaCl here, why did I write Na2O here? It's something which we need to go on. I mean, I need to describe it. But for today, I have chosen the topic of ionic bonding only. Okay. The videos will not be very long so that you can just focus on one topic, one small topic on most of the days you will find at my channel. Do subscribe my channel for more information and, a solid knowledge. I won't be giving you a lot of, distracting information. So today the topic is ionic bonding. If you have watched my yesterday's video, you will realize that ionic bonding takes place between metal and non-metal. So what are metals? I believe in this moment that you know, but trust me, in future, I am going to make a video also on metal and non-metal. So metals are like shiny, they have higher boiling points, they are hard, they are dense, Yes, mercury is an exception. Yes, you are right if you know it. Non-metals, like, they are, of course, not shiny. They can be brittle, they can be gases, or very one exception is their bromine, which is liquid, otherwise they will be solid as well, but less dense, and they will form the bonds with metal. How this bond is formed? First point is this. Second point is transfer of electrons. Now, transfer of electrons takes place from metal, okay? From, okay, please remember this, from metal to the non-metal, okay? To non-metal. This would be, I'm underlining this so that you can remember it. Okay, so that is another thing. They dissolve ionic compounds. Okay, ionic compounds. As you saw that I wrote that before. So ionic compounds dissolve in water, okay, to form ions. To form ions. Okay. For example, when I add NaCl in water, it will become sodium ion and chloride ion. All right. This is the ions. These are the ions. That's why they are called as ionic compound. Now, how this bonding happens? Let's work on this. So there are ways, but I would follow this so that you'll have more clarity in concept. So sodium is 281 and chlorine 287. What are these? These are electron configuration. If you go back, you'll find one of my videos. So this is electron configuration. What is the meaning of electron configuration? The way electrons are arranged in an atom. So number 8. Yes, this is very important in chemistry. So the electron, the orbitals should have maximum of 8 electrons. So this one electron goes straight away with this chlorine and gets, forms the bond because of the transfer. So what we have, the final configuration as sodium as 2,8 and chlorine as 2,8,8, because the last shell electron has moved to accompany the 7 electrons to become the 8 electrons. So now we have sodium and chlorine. And if you can see, the last orbit has 8 electrons each. And now that's why it is a strong, very, very strong bond. It is formed by the electrostatic force of attraction. Okay? Formed by electrostatic, and these are, of course, ions. Formed by electrostatic force of attraction. Where this electrostatic force of attraction, you will see it is between sodium ion and chloride ion. So same way, any metal you take and the same ionic bond will be formed. Okay. We can also do like this. This is also acceptable. Na plus Cl minus. Or let's say that if you want to form the bond between calcium and chlorine, I am intentionally taking this because of the charge. I want you to figure out that why this charge is looking like this. Okay. And then I will talk to you. If you are not understanding, okay, just leave a message in the chat. I'll get back to you. I'm a tutor. I'm still a tutor. So you can get in touch with me if you want a regular lessons for any of the sciences. Uh, okay, enjoy the lesson. I'll catch you later. Thank you so much for watching.